All right. This here is all about you learning two types. We've got set notations and interval notations. Okay? Here are some of the symbols that you must know. It's on this page. You can go to that side of the page, but you need to know every single one of these symbols here. Okay? You will be using them, or the examiners will be using them, so you need to be familiar with them. Just to give you a brief explanation as I go through them, because there's a lot to take in. As I go through them, I'm going to jump back to your exercise and I'll do examples so you can see how I use the language. Okay? But the first part is this one. I think that one you'll see very often, and so it's about you understanding what that symbol means. Often you see it like this in your textbook. They will write something like X with a symbol here, and they may say something like that. Okay? If I break it down for you, what it's trying to say, X is what they call the domain, is the language we use, but essentially it just means X values. So on your X-axis, this is all the X values. Okay, so all the numbers on the X-axis belong to, which is what this symbol means, they call it the element. So you see the word here. It just means it belongs to or is a part of. So it means that all my numbers for the x-axis only belongs to, and they give you an interval. Okay, so this is the interval notation here. So I'm going to write here belongs. So belongs to or is a part of. Okay, so what is my x values a part of? So if you think about the x-axis, there's infinite negative numbers, infinite positive numbers. They're trying to tell you that if you were to draw a scale for the x-axis, that I belong to, so these x values can only be starting at 2, so the smallest number is always on the left. That's by convention. So you can see it's 2 to 3. So on my x-axis, if I put 0 here, then 2 to 3, something like this. So let's say 1's here. I'm not drawing it to scale, but 2 to 3, I'm clearly only working between this set of numbers here, from 2 to 3. That's what they're trying to say. They're trying to say the x values that you can only have, you can't have 4, you can't have 1, you can't have 0.5 or 1.99, and it's only from 2 to 3. Now the question is, do you include the 2 or do you not include the 2? That's what these brackets are for. So I'm going to highlight the brackets. This bracket here, notice it's a square bracket. That means to include. What the next one, which we call the open bracket, so it's a curved one. An open bracket, we say exclude. So you don't include it. So what does that mean? That means that it's saying, if I only want the numbers from 2 to 3, they're saying include the number 2. That's something you want on the x-axis. I want the number 2, but I don't want anything less than 2. Anything less than 2, don't include. Just 2, all the way up until 3, but I don't want 3. You can have 2.99999, but you can't have 3. Okay, that's what the open bracket means. So right exactly at 3, I don't want. But I do want anything less than 3, but it has to be bigger than 2. So, right here, if I were to draw it on a number line, and hopefully you remember when I taught you, if you include it, you use a closed circle. Okay, you fill it in, because you're saying it is there. Whilst at 3, I'm not including it. So I'm going to have an open circle, means it's empty. There's nothing there. But everything in between, I do include. Everything in between from 2 to 3, I can have any number. 2.11111, 2.2, 2.23, they're all included. So how do you show that? We use a solid line. Because the solid line means that as long as I've drawn it, it means it's there. Okay, whereas if I haven't drawn any lines or dots over here, I don't have those numbers. I have from 2 to 3. What you might be used to from year 7 is this language. You might have seen X is bigger than or equal to 2, so 2 is the smallest number you can have, but it is less than, but don't include 3. What you see up here are different languages to say the same thing. This is an illustration of what you're saying. This is the set notation that you'll need to use. That's what year 12s use. This is the language I'm trying to explain to you. And over here is the beginning. When you first started in primary school, greater than, less than, equals to, year 7 and 8, that's where you began. Okay, so this is where most of you are expecting to sit. And when I look at your working solutions, I'm saying, how often do you get that wrong? Because if you get that wrong, then I know. And I know that in year 7 and 8, you struggled with inequalities. You struggled with using the correct symbols, but it doesn't mean you don't understand, because it's pretty easy to say 3 is bigger than 2. So you understand that when you struggle with is the notation. So that's how I tell. I don't expect you to be here yet. If you're using this in your SACs, that's when I know. I know, okay, your strengths are you're sitting up here. Are you familiar with all the notations? That's what this exercise is about. Okay, so I start off with the first one. Element is the one that you often see. Means that it belongs to or is a part of, and it can be anything. Okay, so in this case here, what you write here could be x, could be y, could be f of x, could be whatever it is. Generally, x means domain, y means the range. Okay, so x is all the x values, and y is all the y values. So if you go back to your textbooks, you'll see that's the notation they often use. Okay? Now, the symbols below, any dashes that goes through, which is like a /, that means not element. It's the opposite. It's like when you learnt back in year 7, you had equals, and then a / through it means not equal to. Yeah? Same thing. So if you had element, then a / through it just means not equal to. If this means a part of, that's not a part of. Next one that you might see. These two. What is this symbol? This means a subset. What is a subset? You can think of it like this. Over here. Now these are some numbers that you may use more often, but some of the ones that are most common, Z, Q, and R are the ones you tend to use. But what's a subset? Subset means that you are a part of a set of values. Listening. Say the numbers 1 to 10. 1, 2, 3, 4, 5, 6, 7, 8, 9, and 10. A subset, so if I call this a group, so I call it a set. Let's call it set A.
No worries, sir, no worries.
So
I'm going to say something stupid.
Should there be a C on the outside of
Like here.
Yeah.
Oh, you're talking about imaginary numbers.
Yeah.
We can, but
Yesterday, sir.
We just learned it yesterday. We
Yes,
learned
we did.
like 5 million years ago.
good.
Nobody else does that.
Then we need to make sure everyone else knows the methods. All right, subset. Subset means that you are a part of this group. So say, for example, I said B, and I said the numbers for B in this group, I could have 2, 6, 8. Can you see how 2, 6, and 8 can also be found in A? So 2, 6, and 8 are already part of A. So if I were to visualize this for you, this is A, then B is only a part of that. So we call that a subset because it's part of it. Okay, so if I wrote all the numbers 1, 2, 3, 4, 5, 6, 7, 8, 9, and 10, we can see that B is 2, 6, and 8. So this is B. That's why we call it a subset. Okay, it's already a part of it. Everything's included. It would not be a subset if I then said B also includes the number 11. See, that wouldn't be a subset because it doesn't fit into it. It has to be a part of that group. Okay? Right, now, let's do the exercise over here just to see some of the notation. So I've introduced you to element. I've introduced you to subset. What you'll likely see as we move down, there are R's and R pluses. Just to give you a visualization, because we talked about subsets here. This is how you started off learning numbers in mathematics. When you were in primary school, you learned how to count. You started off here, which we call N. N stands for natural numbers. What does natural numbers mean? Numbers that you naturally do. So 1 table, 2 chairs, $3. But you never say -1 chair or -$2 until much later when you learn to use negatives. So in natural numbers, it's counting. And it's counting, it's positive. It's positive, they're whole numbers, that's what we call natural numbers. So in primary school, you start off learning how to count. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, and then you go into the hundreds. So natural numbers are only positive and whole numbers. Then when you get to year 7, you start to work a bit more, and they use the letter Z, which represents integers. That's essentially whole numbers again. You can have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, but this time they introduce negatives. That was the first time you would have learnt negatives in year 7. That's when it got confusing. Double negatives is positive, or plus minus becomes minus. That's where a lot of students found it confusing between -3 plus -7 or -3 times -7. A lot of students get confused with what you do there. Double negatives become positive, or is it -3 plus -7? Is it meant to be a -10, or is it meant to be +10? Which one is it? That's what they get confused by. For those who are getting confused by my language just now, -3 plus -7. So my year 8s struggle with this concept because they get used to doing this. So multiplication, double negatives is positive, 3 times 7 is 21. They get that, they do that really well. But once they get really well at that, they mix up with this one. They're like, oh well, negative, positive is negative, negative and negative is positive, so 3 plus 7 is 10. Why doesn't that work? You see, like, it seems logical. That's what I did for this one. 3 times 7 is 21, double negatives is positive. And why don't I do the same for plus? Right? And it's the misconception. If you're learning rules as they are, this is where misconceptions come in. If you understand what the symbols and why it happens, and I try to teach my year 8s the why we do it. If you understand the why, then you're less likely to make those mistakes, or you just practice a lot. Yeah? Then you move into year 8 and 9. Year 8 and 9, once you learn your negatives, we revise what you practiced in primary school with fractions, multiples and factors. We call Q as your rational numbers. By definition, rational numbers means, and they say, it's ratios of integers. So it sounds really confusing. What they're trying to say is, if you can write any number as a fraction, so ratios, and both of these numbers, both numerator and denominator, are integers, then that's what we call rational. So an example, 3 is a rational number because you can write it as 3/1. 3 is an integer, it's a whole number, it's positive. 1 is a whole number, that's why 3 is a rational number. 1/3 or 0.3333 is a rational number because you can write that as 1/3. That's what we call rational. And then you learn things like pi. Pi is not a rational number because that goes on forever. 3.1452 carries on. We can't write that as a fraction. Root of 2, whoops, wow. Root of 2 is irrational. Type in the calculator, it goes infinitely. We can't write that as a fraction or as a ratio of integers. So, where do irrational numbers fit? That's where R comes in. Everything that doesn't fit in any of those boxes there that we just talked about, R is every real number. And what that means is any number that you can think of. So root 2, pi, 1/3 here, 3 there, and then 1, -2, and then 3, 4, and 100. That's essentially the number system. So when you say R, it's essentially all the numbers that you've learnt up until now. Unless you're doing spec, which is what Ollie was talking about then, we don't have imaginary numbers here. That's complex numbers. Okay, but for methods, you don't deal with complex numbers, you only deal with that number system. So you can see, that's why I said at the beginning of the year, you've been trained to do methods. From primary school all the way up to now, you've done every single step of the way is for you to do methods, because that's what methods is designed for. It's designed to cover from N, Z to Q to R. So everything here, everything that I'm saying here is familiar in some way. Okay? All right, so those are the symbols. That's what they mean. Real numbers. So let's go back here. Let's do an example just to get you going here. Question 1. Let's read the notations here. So it's more of a language. When they write a capital letter, this means it's a set. What is a set? Think of it as a group. A collection of things. Okay? So in this group A, we write A equals 2, and you have to use what we call braces. Notice they are squiggly brackets. It looks like that. We always use those squiggly brackets, not the open brackets and not the closed brackets, because they mean something else. You have to use squiggly brackets, or they're also known as braces. Okay? These braces, you only use them when you're listing. When you're listing items, that's when we use them. So notice they're always using squiggly brackets here, squiggly brackets there. What's part of Group A? Group A has 1, 2, 3, 5, 7, 11, 15. B has 7, 11, 25, 30, 32, and C onwards.
So my favorite version of Star is
1A. A is this symbol and B. Back in year 7 and 8, you learnt this symbol. What does this symbol mean? What does symbol mean again? Anyone remember?
intersection.
What does intersection mean?
It means both A and B.
Very good. It's what's in common in both A and B. Both A and B have the same numbers. So I'm going to write here common to help you remember. Okay, what's in common? So let's have a look at Group A and B. In Group A, I've got 1, 2, 3, 5, 7, 11, 15. What do they both have in common? They both have an 11. They both have a 7. And that's about it. So your final answer is, you would say in the Group A and B, or A intersection B, using your squiggly brackets, you then say what numbers or elements are in this bracket that's in common. And I would say it's 7 and 11. But that's how you should write it properly. A intersection B equals 2 squiggly brackets, so using your braces, 7, 11 squiggly brackets.
And which
What?
one is the subset? You might know, you call it the element of the symbol.
You could, technically. You could.
Why do you wrong?
Yeah.
I guess that also.
We don't normally do it, but technically.
That's what our point is.
Yeah. Would you lose marks?
Would I lose marks if I did that?
I think you would throw off some examiners at the start, but they
So
would.
I needed to like that.
Correct. Yeah. But often they don't ask you to do this anyway. This is usually just to get you started, but you eventually do probability, so you won't need to write the way I'm showing you, but it's to practice when do you use braces and when don't you use braces. Okay? So what I don't want to see is in your exercise books, I don't want you to write 1A 711. Okay? Because that's not training your set notations. I actually want you to write A intersection B is equal to, and then using braces, identifying the elements in those groups, and then finish off with your braces. Okay, so I don't want to see 711. I know the answer. I don't want to see the answer. I want to see how you're doing it, how much you understand of the language. Okay, so the first part is intersection. We've done intersection. What about this symbol over here in C? What does this symbol mean in C? Anyone know? What's that symbol mean? Union. But what does union mean? Means or. I like to think of it as unity, or unite, or include. So what it's trying to say is whatever's in Group A, include it with Group C. So in Group A, I have 1, 2, 3, 5, 7, 11, 15. But in Group C, I already have the 1. I already have the 11. So the only ones that I don't have, 7, 25, and 30, I'm going to group them together. So here's my answer. In Group A Union C, I should have... Oh, why did that come up? Yeah. Squiggly brackets. Here we're going to put a union. And I'm going to write all the numbers in A. 1, 2, 3, 5, 7, 11, 15... 25 and 30. I just realized they also have a 7 already. So I'm missing 25 and 30. So that together, with your squiggly brackets to close, that's how you describe what the element of union is. What makes this tricky is when you start to combine the languages. So if you have a look at F, what is F asking you to do? Notice the brackets, those open brackets, just like BODMAS, means you have to do A intersection B first. So what's in common between A and B? And then union that with C. So if I did F with you right now, A intersection B, you need to do that first before you union it with C. Well, we already got the answer for A intersection B. We did that here. It's 7 and 11. Union that with C, well, what's in C? C is already 1, 7, 11, 25, and 30. So if I put it together, technically, it's just 1, 7, 11, 25, and 30. Because they already have, technically, A intersection B is a subset of C. Okay, so that's why I'm just writing down what's in this group and what's in this group, combine them together. That's what union means. Okay?
Before you said on the right there was like a chart, you said proper subset and like a subset.
Over here?
Yeah.
Like that?
Yeah. The two ones highlighted here.
These two.
Yeah. What were the difference between those?
The difference between them is that when you're running a subset, which is this one that we normally do, this one means that it's a part of, right? A proper subset would imply that when you're drawing them, it is within, but it's not inclusive of those values. Okay, so how would I illustrate this? So S is a subset of T, so it's a part of T, but it's not completely engulfed by T. Does that make sense?
So you show it like a Venn diagram.
Yeah.
Like
so like that. That's a like a subset,
okay.
but it's not completely
so like the example on the right, when you have the circles, yeah. So if you had like the 11, it's on the outside. Would that be a proper subset?
Correct. Whilst this one would be A, B is a subset of A.
Yeah, and then if it was inclusive of the 11, it would be B, and it's just a proper subset of A.
Correct. Yeah. All right. Anything else over here? No? All right. And then finally, the only extra note that I normally tell my year 12s are, so because that's all real values, that's essentially saying from negative infinity to positive infinity. When you're doing infinity, remember you don't include it. So it's always in open brackets. Never do this. Okay, so infinity, we don't know what number that is. So conceptually, we use an open bracket to say it's a number that's very large, we just don't know what that number is. Okay? Next thing is, well, what's the difference between R and R plus? R plus means all the positive numbers that you can think on the scale from 0 to infinity. The difference is when you write R plus, it also doesn't include 0. Okay? That's why, can you see why they did union 0? Because they're saying R plus is every positive number, so 0.01 is okay, but right at 0, I don't have that number. That's why they're writing R plus union 0 means I'm going to include 0 as well. Because naturally, R plus does not have 0. I should write it as it doesn't include 0. Okay, so R negative or R plus doesn't have the 0 line. Other than that, that's essentially what you need to be practicing in terms of language. I know it's only half the session. Usually I'm going to split it up into 2, but next session I'll be going through 5B and 5A just to whip through it, because you do need to complete chapter 5, which is quite large. If you have a look at the number of exercises, you've got A, B, C, D, E, F, G, H, and your exams are in week 7, isn't it? And we're coming to the end of week 4. So you've got week 5, week 6, there's got to be a sack at some point, and you've got to have some time for revision. True? So you can imagine the speed I'm going to be going through these. I'm going to make videos in advance so that you can watch ahead of time, but it does mean you need to keep up. with a very different pace after this.
So
Okay?
18 is the longest chapter.